New Year, and thank you for coming to the first Dash meeting of the new year, 2023. I'm displaying right now what we talked about December 14th, just before, sorry, we all went on the break. And these were the different PRs we talked about that were underlined here, just the different things we talked about, and you know, the conversation around them. So there was 297, 302, 301, 303, 304. And I did put these notes in when I post the YouTube video. I usually put these notes inside the description. So I did do that, although I didn't send out notes particularly that time. So that's what we talked about last time. And because it's a fresh year, I thought I would open it up, and I'm going to stop sharing this screen. I'll share a different screen. And I'll just share my regular screen here to see if there are any PRs or items you guys want to talk about today. I'll turn my camera off.
Yeah, so we have one pretty old PR.
Is this Anton?
Yeah,
yeah, behind.
Yeah, 293, so that's also almost on the bottom. Dash ENI removed test cases. Yeah, so that's the one that we presented pretty while ago. Yeah. So I fixed the comment that there was too many files there. So right now that's only 2 files, test and the test plan. That's it. So like, please take a look if there are any comments, any other comments. So it would be good to merge it.
Yeah, this is what we said last time, separate period. Yeah, okay, let's take a peek then. Can you guys see it? Let me open this up a bit. So Chris said it looks good to him. I believe those comments were from, Prince and Gohan, were they not, Anton?
Yeah,
to do the separate, okay. Yeah, I'll let you guys chime in then. Prince, what do you think?
Sorry, what, Kristina?
So the last time we looked at this PR before we left for the holiday, there were some comments from the internal SONiC team about creating a separate file for common functions, making it a little bit easier to review. And so Anton feels that he did that.
Oh, okay, I didn't get a chance to look.
And then Chris said it looked good to him, so.
Yeah, basically Anton addressed the comments from
I think I remember I saw that. Maybe I didn't get a chance to sign off.
Sure.
But I saw that. I think it's separated. Yeah.
Okay. Thank you, Prince. And
yeah,
thank you, Anton.
Anton also is making some fixes in the ECMP area in the PTF in the main SCI repo. So he'll be creating a PR for that. That will directly go to the SCI repo.
Okay.
Yeah, which will help us as well over here. There's another PR. There were some issues in the PTF that we had fixed and created the PR in the SCI repo, and that's now gotten merged. It's the PR 176. So with that, now we are going to be able to use SCI repo as submodule within the Dash repo, and we don't no longer need to use the private repo because of this fix is merged.
I'm just taking notes, Reshma, while you're talking. So
sure.
Did everyone get that and get the ramifications of that?
Yeah, so I will paste the PR number in the chat. So with that fix now that is being merged, we are able to use the SCI repo directly into the Dash repo without having to use the private repo that we were using earlier for Dash. Has Volodymyr Mitnick joined?
I got it. I'm just going to pull this up just so people can put their eyes on it real quick. So here we go. So P4 Lang, PTF. This is the one, guys. So thank you.
Thank you.
Anyone else have a PR they want to cover?
So I have one PR, Kristina, like before the vacation, we discussed about clarifying on the underlay routing.
Okay.
Have that
Yeah, and
PR
that
discussed.
one was,
The second one.
I'm sorry,
The second one. In
the second
Egress.
one. Okay.
Basically clarifying what attributes we will be using and how the underlay general work.
Okay, so we need Marian to take a look and me. Okay.
Prince, this is updated in the HLD, right? Okay.
Yeah. This is basically.
Three dot.
Yeah, so one minor change is like the VNET number. So in theory, VNET is not translated hardware resource, so the number was some confusions. So people were asking by 1024. If you go back to the scaling section.
Yeah, let me get back there.
I just clarified that it's a software limit.
Okay. Sorry for watching me scroll, guys. It's my first day
Scroll
back.
up a little bit.
There we go.
Yeah.
Okay. Number of VNet is a software limit, as VNet by itself does not take hardware resources. Limited to the number of VNI hardware can support.
Yeah, in theory, it will be like, unlimited.
Okay.
So, and then I also clarified between the outbound route scale versus the inbound. Previously, it was just routes per ENI and it was 100, and people were asking about scales.
Mhm.
So
Got it.
the maximum that we anticipate is like 10K. I know that previously I mentioned as that it as 1K max, but
Mhm.
then there has been some other discussions where we could also have peering scenarios, in which case, like if 10 VNets appeared, then so max 10K or 12K, that range.
Does that make sense to everyone on the call?
Is the total number of routes now 64 times 100K?
Yeah,
Maximum?
so I didn't change that part. It's just
Right.
it was always routes per ENI was 100K, but now that scale is for the outbound route. So it is 64 times 100K.
Yeah, that's a lot of routes. And we also wanted to sort of have a breakdown of IPv4 versus IPv6, if that's possible. Yeah.
Yep, I believe
Yeah,
we
I
are
think.
still working on that.
Yeah, I think that's right. So we have, at this point, we know about the 100K as the total limit, including each. But
Yeah, Prince, I have that filed in our internal Azure DevOps for the SDN team, and I can mention you if you want to see it, or I can give you the number. So we can keep looking, have a marker that we're looking into it. We also had, I don't know if this is related, guys, but in that same conversation, when we were taking notes, we said Prince may update this section, and he did. And then, we need to update the destination MAC and BMV2. Since we have Marian, do we want to talk to him about this or ask him?
yeah, so the other section is the underlay routing part, right? So that's also updated.
Okay.
The second line.
Okay, right.
Yeah, in the HLD, Kristina, the underlay routing.
If you go to 335.
Yeah, work on it. Okay.
Prince, if you can remind what is the new change?
Oh, Krishna, can you go back to the PR? So we'll.
I can barely hear you, Prince.
Oh, can you hear me now?
Yeah.
Mhm.
Yeah. If you go back to the PR, we have the diff. So previously I didn't capture the actual psi attributes. So now the attributes are specified, so it should be clear on.
So these psi attributes here?
Yeah, that one, and also in the description mention
Mhm.
like how different attributes are should be created and used for underlay routing.
Okay. So go back to the files changed and
Yeah. So yeah, the underlay routing section. Yeah.
now we're back here. So was there a question, Reshma, about this section here?
I think we wanted to clarify in detail how the destination MAC will be updated when we forward the packets after the LPM lookup.
Oh wait, that is the regular neighbor table, right?
Okay.
So that's why it is like neighbor entry has both IP and the MAC.
Mm-hmm.
Oh, okay. So neighbor is IP and MAC.
So again, the Intel test cases use that routing and the program routing interface and all that. So it sounds to be the model that we would use here.
Mm-hmm.
Yes.
Okay, so this implies that we have to implement some amount of underlay routing, the basic part that is there, and that will come directly from what's there inside.
Yeah.
Okay. Got it. Thanks, Prince. Any other questions about this PR, guys? No?
Bud here, just a question on that. I didn't have time to look at this before, so this might be a dumb question or something we covered before. It says in the text there that the Tor advertises a default route to the appliance.
Mm-hmm.
Is there ever anything except a default route advertised?
Sorry, is it what?
Is there ever any route other than a default route advertised?
I mean, there is no restriction because it's a generic BGP session between the appliance and the Tor, right? So whatever Tor can advertise, like maybe the gateway or some specific routes, there's no no real restrictions there. But in the current deployment, what I see is the Tor just advertise the default route.
Make this more generic. Why are we calling it a Tor? It's a smart switch. It could be a T1. It could be somewhere else in the network. We always mention it like it sits below a Tor, and it's kind of
Okay.
going to
Yeah,
be
I can make
outdated.
that change
Yeah.
to mention that it's like the connected BGP peer or something like that,
Yeah,
or the network device. Yeah.
it's more likely we're going to connect to the tier 1. So yeah, just to make it more generic.
Sure. Yeah.
So today there are only default routes advertised, but in the future they could be specific routes and any specific number of.
Just thinking out loud, I don't know why we would manually program. That would be difficult.
No, I think for the underlay, we just need the default route, right?
Mhm.
Don't need.
Default route points to 1. If that goes down, then
Yeah, 1 or
some
2,
BGP.
like, or whichever advertisement.
I believe there was for specifying 2000 BG, something like this for play.
I think
You're breaking-
we
you're
need
breaking
a little
up.
more
HA
clarity,
probably was
Marsha.
around 2000.
Right, yeah, you're breaking up.
One more time, Marsha.
Oh, sorry. I was saying for BGP, I think there was a document I saw a few months back requesting 1,000 routes for underlay, and I think with HA 2000 max. So probably in that range of scalability, from what I remember. I'll find the document and I'll point to it.
I got another question too. Is like, sometimes we just decap the packet. There's nothing in the flow, the airplane flow, that would say what to do once we process the packet, decap, uncap, whatever. It sounds to me that we go directly to writing all the time, right? But sometimes we also decap packets, right? That's not underlay per se, but we're still gonna write them, right? In other words, whatever we do to the packet at the end, is there any condition where we wouldn't write the packet, or we just do writing, period?
Well, my understanding is we look at the mapping table and we look at the routing. Right, Prince?
Sorry, what, Christian?
Look, we're talking about underlay routing here, but
Mhm.
sometimes the packet gets decapped as well, right? As part of the processing. I don't recall the case, but there is a case where you
That's
decap.
for the inbound routing, right?
I'm talking outbound on the outbound. We never decap on the outbound.
There is a route direct
Route direct,
action
yeah.
Right.
as far as I remember.
Right. So, okay, let me rephrase anyway. Is writing on the outbound the only ever action we're gonna have?
On the outbound, it will be only routing.
Okay, thanks.
And that was, who was talking there? I'm
Why
sorry.
do we, I'm trying to figure that out. I thought we did everything on the outbound that we do on the inbound, including ACLs, et cetera. We don't?
ACL should be there. This is
Yeah, I think the
specific.
question was about the NCAP, DCAP, right?
Okay.
Yeah, so whether
All
we
the rest
do
of it
NCAP
still
or not.
holds true. Okay.
Yeah. But I believe, we do have to do NCAP depending upon which way we are talking about outbound, right? Whether it's the host or the network, right? So we have to really specify which outbound we are talking about.
Trying to figure out which action you're talking about that
Yeah.
you're confused on, because it kind of goes in a flow. I'm trying to figure out what is your question? Is it you want this flow diagram changed? I'm not sure what it is that you're trying to get.
Me? Oh, that was just
Yeah, that's it. Yeah.
you process the packet and then you gotta send it somewhere. Is the sending somewhere is writing only, or is it gonna be something else? It sounds to me we just do writing. That's all.
Yeah. And then you
Because
do the
right now there's no option anywhere to give options anyway of what you can do. So
So I think, Vincent, there are two parts, right? One is on the actual packet where we will do some sort of encapsulations, and then
Here.
those actions are part of the overlay routing tables, right? And then you have the underlay for the final packet forwarding. So in that underlay, it's only routing.
Right.
Yeah. Just to clarify.
Thanks, Prince.
Do we need to clarify the flow diagrams at all to unconfuse that?
Yeah, if we do, please let me know. I drew this one, so I'd be happy to change it or improve it. Vincent, just let me know.
I think this is the overlay flow table. And I think what we're talking about is once this is all done, you still need to forward it. So you route it to the next hop. That's not in here probably.
Let's create the
Yeah.
flow. You know, it's here, create the flow.
It's the forwarding side of things when you're all done with this processing. Yes, that's correct.
So on the underlay routing, in terms of implementation, there's a big difference between having a default route or maybe 2 default routes and like 1,000 routes in both like computation and overhead. I just want to make sure that there's actually a requirement to do something other than a default route or 2 default routes. And the statement that we need more than that, like maybe 1,000 routes or anything other than a single route, is an actual need and not just being done for completeness.
So I think he already answered that. We don't use it. We just have 2 default routes. But the actual open source document here shouldn't prevent somebody who might have a need for that. But we've already answered it with, we use 2 default routes. But that's just Microsoft though. This can be used. This can be used by other companies. And if it is, they might have different requirements. But ours is 2 default routes.
Are those default routes, how are they provided to the control plane? Through the next hop and router ID and all those things that we just talked about? I guess I'm looking, is there a specific side API for those default? Or
Prince, I think this is part of a BGP session. I mean,
Yeah.
Yeah, but it needs to go through side to get down to our control plane. That's what I'm getting at.
mhm.
And are we basically there using the router interface and whatever, like those Intel test cases are using to program the DMAC and SMAC for the route?
So you're saying that it's not defined in this SI how to pass that down? Is that where we're?
No. So in a
Here's
generic
this.
way, when you're gonna forward your packet,
Yeah.
you're gonna look up those 2-3 tables for router interface and whatever. I don't remember those things, right? Next hop, router interface, right? But that's fine. That's generic and it will work and it's programmed through the SI with the proper APIs. We just talked about this like 20 minutes ago.
Mhm.
Now, if we only have 2 default routes, we may want to optimize the data plane for that without doing like 3 lookups to just get to, we can optimize for that. What I'm questioning is the 2 default routes you're talking about, how they're going to be pushed to the side. Are they going to use the same network neighbor, router interface, and next hop definition in the side level?
So when we push the default route, it will have, let's say if you have ECMP, right? Then it will be like 2 different next hop for that default route, right? So it will be pushed by the SI with 2 next hops for the same default route.
So it will use the side next hop definition, router interface definition, and all that. Okay.
Yes.
So just for 2 routes, we should see how, whether we need another LPM table because here we have a complex LPM table that we just saw in the other diagram, which includes ENI along with the destination IP, right, to look up. So yeah, in the pipeline for the underlay, do we need another LPM lookup? Those are the things we should figure out, just for 2 rows.
Sorry.
Maybe let's take this as a topic item, Kristina, because
Yeah.
I also want Gohan here. I don't want somebody reversing decisions like after the fact, wants this whole conversation over again. So when we get the people here, I think that we do need to resolve this. I think we hear that it would be much more optimal if we didn't have to do another longest prefix match just for two default routes. But let's make sure that we have the right people in the room to make that decision, or to have option for that is another way to do it. But let's take it as a topic item. So it seems important enough to we could take it up in the next meeting.
Yeah.
Just just need to take the note to take it up and make sure that the appropriate people are here so we can close it.
Yeah, I got it. I am typing as we speak. So to be super crisp then, we just need to know, we need the discussion and the answer to the question about when we're optimizing, do we need to have another longest prefix match table for 2 default routes and the ramifications around that? Is that right, guys?
Yeah. Sure.
Okay.
Yes.
Thanks. Okay, thanks. Got it. Okay, and then
Essentially,
I
it
can't.
could eliminate a complex table, so it can create higher connection rates is what they're getting at, and it doesn't take as many resources. So.
And
Problem is if we leave it open and they have to make tables that are like 10K routes and anything like that, they have to reserve this space in the first place, and then you have to do the LPM in the second place. So it doesn't seem optimal.
Makes sense, and we only have so much memory and resources. Yeah. And then we did answer the question that we're using the SONiC-HLD API. So, okay. So, any other PRs or something you guys want to go over today? Sorry, I'm managing.
I think the next one we want to discuss is the service tunnel and private
okay.
link, right?
Sorry, and I'm
unless any other PRs people want to discuss.
Sorry if I sound distracted. I'm managing like 4 windows at the same time. But is it this one right here? The service tunnel route type?
Yeah, but before we go there, I think I would like to give an introduction on the service tunnel and.
Okay.
That'd be awesome, Prince. Let's do that.
Okay, so I'll share my screen.
Okie doke. Thanks, Prince.
Okay, can you see my screen?
Yeah.
Okay, so this one is part of the SONiC-HLD as well. I think we also have some other detailed section on the service tunnel and private link packet processing. But in the SONiC-HLD, it's at a very high level. So we have this section for VNET to VNET packet flow. So service tunnel and private endpoints like private links are kind of the next phase. It's not the VNET to VNET, like it's not the regular VNET to VNET scenario. So it's solving other customer customer use cases and scenarios. So I'll go over the northbound schema changes and how the packet flow happens. But at a high level, the service tunnel is for like like different customers want to access a common shared resource. So let's say like the storage, right? In this case, there will be multiple VIPs that are assigned to this endpoint, and customers can access it through either the public reachable or the internet routable endpoints. That's the service tunnel scenario, or like within a VNet, like using the private endpoint. So again, like there are like documents in the Azure about what is private link and what is service tunnels in this section. So there are like more details on how the or what are the different cases for that. But like I said, like at a high level, it's like accessing a shared resource either through public endpoints or through private endpoint, right? So I think maybe when we go through the packet forwarding section, it will become more clear. So the one thing I want to highlight is because it is not within a VNet, where the endpoint may want to install ACLs or those things based on, let's say, the encoded VNet ID and region ID. So that's why in this scenario, there are actions that kind of encode the region VNet ID, subnet ID in the packet itself. So this is kind of a transposition from IPv4 to IPv6 with different encodings. Okay, so yeah, I think it's a bit of confusing, but let me go over the details. But Gerald or someone, do you want to extend on what is service tunnel or private link scenario, or? Okay, so let's move to the changes that is being done to achieve the service tunnel private link forwarding, right? So for one is in the ENI table, we will have the encoding for the private link. So this is only specific to private link. So there are two cases, right? One is service tunnel, another is private link. Service tunnel is the routing to the public IP, and private link is routing within a VNet by associating a private IP to the public endpoint. Okay, so let me explain that in detail. So this is one is the encoding, another is the SIP to use in the underlay. Then let me come to the routing table. So in the routing table, this is the main change, right? So we know how the VNet to VNet work, right? Based on how it is explained in the example section. But for the service tunnel, we have these four extra attributes that are being added. Like basically, you'll specify the overlay SIP, overlay DIP, underlay SIP, and underlay DIP. So overlay SIP will be like an IPv6 transposition from the IPv4 packet. And similarly, overlay DIP is also an IPv6 transposition from the IPv4 packet. Maybe like what the example will be more clear, and we can come back to this. So the same routing table, depending on the action type, if it's, let's say, if it is service tunnel, then it will pick up all these attributes. So that's why it's optional. So for regular VNet, these attributes are not not needed, but for service tunnel, this will be the one that takes effect. So the two changes are in the tables are one in the routing table, LPM route table, and another ENI table for the private link. So let's go to the example section. Yeah, so here is the service tunnel example, right? The route table will have an action called service tunnel. There are two actions associated. One is a 4 to 6, like IPv4 to IPv6 transposition, and the second action is the encapsulation, either NVGRE or VXLAN. It can be either one, but I'm having the example as NVGRE. But remember, in VNet to VNet case, there is just one action, which is like map routing or static encap, something like this. So it's single action, right? But for service tunnel, there are two actions. One is a transposition, and then the other is encapsulation. Now, the route table will look like this. You have a packet destined to some IP, and then the action type is service tunnel. Then here we specify the overlay SIP and overlay DIP, right? And then in some cases, we'll specify like you have the underlay SIP and underlay DIP as well, but depending on whether it is available or not, the packet transposition will happen accordingly. So now one example is, let's say the packet is just a packet is coming in this ENI destined to 5121, right? So 5121, it will hit this entry and the action is service tunnel. So the first action for the service tunnel is 4 to 6 transposition. So you get a packet from 10111 to 5121. So it first gets transformed with overlay SIP, which is being captured here with : : 0. So the last 32 bits of the IPv4 get transposed to this overlay SIP, right? So you have an overlay SIP which is an IPv6, and the last 32 bit is your IPv4 destination. Like this is what 5111. No, this is the SIP. So it will be like 10111, and then you have the overlay DIP, which is also mentioned here with : 0. So the overlay DIP will get transposition to the first like 64 bytes like this, and then your last 32 bytes will be the destination IP. So this is the first transposition, like 4 to 6, and then you have the second action for the service tunnel mentioned as NVGRE. So you encapsulate the packet with NVGRE, and then for the NVGRE, you need an overlay IP. I mean, the underlay SIP and DIP, right? And you get that from this table itself. Like underlay SIP is 4121, right? Underlay SIP as 4121, but since there is no underlay DIP specified, it will use the packets IP, the destination packet IP itself. So this is how the packet transposition happens. Okay, and the other example is 6121, where you have both underlay SIP and DIPs mentioned. So the same kind of IPv4 to v6 transposition, but for the SIP and DIP, you have the attribute, so it shall use from the route table. So this is about the service tunnel packet forwarding. And before we go to the private link, any question here?
No question from me. It looks great.
So
Anyone
far,
else?
we have discussed mostly VXLAN. Now we are discussing NVGRE as well.
Yeah. So in some endpoints, right, where we send the packet, it only supports NVGRE. So this is like we might have both support, like NVGRE or VXLAN. Yeah. So
I have a question on the case where the underlay DIP is not configured in the entry. It says line F, it'll use the destination IP from the packet.
Yeah.
Yeah.
Is that the overlay?
Yes. The original packet's destination will be like this one, right? This 5121, right?
Okay, and the 50.121 is the overlay.
Overlay,
IP.
yes.
Okay.
Yes.
Okay, so you're saying if the dest IP isn't configured, then use the overlays dest IP as the underlay.
Correct.
Dest IP. Okay. Okay, thanks.
Do we have a way to make that clear? Because since we've been over that a couple of times, maybe we should just put it in the document.
To use from the overlay, right?
Yeah, if not present.
Yeah, okay.
That way we won't get that question again.
Okay.
Prince, I have a quick question on this routing table. So will other VNets routing table look the same? In other words, this service tunnel endpoint, the shared resource, will be accessible using the same IP address?
Service tunnel endpoint. See, if you see, these are public routable endpoints. So Hanif, what was the question? So
my question is that these public IP addresses will be the same for other VNets as well, right?
For other ENIs?
I mean, just let's say there are multiple customers, right? They're trying to access
Correct.
from their own VPCs or VNets.
Yes.
Will they be using the same IP address?
Yes. It could be like the shared resource can have multiple VIPs, right? Multiple public IP addresses, but it is possible that one multiple ENIs can have the same destination IP. Yes, but probably the overlay zip dip things will be different depending on the VNet ID.
Right, and then the how the reverse forwarding will look like. Do we want to cover that as well?
So when you make this transposition, you will create a flow, right, for both outbound and inbound.
Okay.
Yeah. So for the reverse path, we'll have to do the reverse transposition. I think, yeah, I'll take a note and I'll also update the reverse path. I only briefly mentioned at in the section above, like because it's there's nothing from the configuration side for the reverse path, but based on the outbound flow, you'll create an inbound flow for this.
Okay. All right. Thanks.
Yeah.
Thank you.
So
Okay,
when we create the flows in the tracking table, this will, in each direction, it will be the addresses that are completed the transposition, right?
Yes. Yes.
And all the ENIs will have the same destination IP if it is a private within the same VNet. If it is public, then of course any VNet can access it with that IP address, right?
Yes. But for private, yeah, I'll come to that. It's part of the mapping table. So it's like within a VNet tree. The same service can be like, having a private endpoint, and it will be more like a VNet to VNet scenario. So I think
for VNet.
Yeah, it's part of VNet. So the private link is.
What is the ENI that going to be used for the service tunnel? Because it's only GRU of VXLAN, right? So there must be a ENI value.
Yeah, so the key is mentioned as part of the action.
Oh, the key is mentioned. Okay. I see. For the reverse direction flow, what would be the packet look like? Is it going to be encapsulated or not encapsulated?
From my understanding, it is encapsulated with the same, same as how we do the outbound. It will be similar encapsulation.
You also have those underlay, those SIP and deep. Sorry,
yes.
the overlay SIP and deep.
That's right.
Okay. So when we try to create the tracking, we're tracking the V6 connection. Yeah, when you say we're creating the tracking table, so what kind of IP address we're using
We
to
should
create
be tracking the V6. Yeah.
Oh, we're tracking the V6.
Yeah.
Okay, that means that so when we try to create the connection tracking, we use the overlay IPv6 IP plus plus a port number to do the to create the connection tracking table, right? So
Yeah.
okay. Okay. Is that mentioned in the document?
Yeah, I think the inbound is based on, I just had a like a high level statement about like the connection tracking to be based on the outbound flow, but yeah, looks like I'll clarify more on this.
Yeah, that will be very
Yeah,
important.
yeah.
Because I don't know, like look at the pipeline. I don't know when the connection tracking table being created. Is it after all these actions we create the connection tracking table, or before that?
So if we look here, in the flow, it's after the routing, the connection track update is done.
I see. I see. Oh, makes sense. Okay. Okay. Okay.
Okay.
So maybe this particular part we need to, you know, make it more specific so that the people knows that this is tracking the modified header. Right? You transport this the header, right? So.
Yeah. Okay. So. Okay. Now I'll update that. Yeah, the next one is about the private link. It's again like it's kind of an extension to the service tunnel, and enables the customers to access public facing shared service via the private IP address. So this will be within their VNet, right? So it's basically same as VNet to VNet, but there are kind of encodings that are required here. So it's like slightly complicated than the service tunnel. So here one example is you have the ENI table, you have the routing action type for private link. Again, like 2 actions, 4 to 6, and then NVGRE as encapsulation. Then you have the routing table, right? Sorry, this is the ENI table, and the encoding is like this. So let's say there's a field, offset, size, and value. The field, offset, size, and value. So if this is the encoding, it is common encoding for all packets that is going out of this ENI, right? And then here you have the underlay SIP, which is a common SIP for all the private link underlay IP. Now the route table, you will have an entry like this that says like 10, say packet destined to 10 to 0. Then you have like VNet direct, and and here you can specify the overlay IP. This is like the regular VNet direct example that was captured as part of VNet to VNet. Now the thing here is when it goes to the mapping table. So here you can see the mapping table. You have a 10.2.0.6 a specific entry for the mapping table entry, and then the routing type and all the remaining things are specified here. So let's take an example like 10.2.0.8 from 10.1.1. So LPM lookup hits for this table, right? And then the action is VNet direct with the mapping lookup key of 10.2.0.6, right? And then the action in the mapping table is private link. So for the private link, there are 2 other actions like 4 to 6. So 4 to 6 transposition. This is what will happen for all the private link cases. So for overlay SIP, using PL SIP encoding, like here is the encoding is captured as part of ENI. Like it means that from this overlay SIP, modify these fields, right? Like field 11, length of 1 with value 1. So it will change, like if you notice here, where is that? Yeah, so it changed to FD30 instead of like FD40 became FD30 because the encoding is mentioned that over here, like what to use. And similarly, the 48th offset and size 48, you have this value. So you change that value here. And then finally, the last 32 bits is again like the same mechanism. You just replace the IPv4 entry with for that last 32 bits. So this is how the transposition happens for private link. And similarly for the destination IP. So here, like, overlay dip. It's again like sometimes you will be provided with the last 32 bits as part of the overlay dip. In that case, there is no replacement of IPv4 to IP like IPv4 to the last 32 bits. But if it is provided, you just directly use that. So these are the two 4 to 6 transposition, one for the SIP and another for the DIP.
Got it.
And yeah. The second action is similar to the service tunnel. It's just an NGRE with the key here, and you have the underlay dip and underlay SIP from the mapping table. So you have, like for this example, underlay IP is mentioned. So it uses the underlay dip from this mapping table, and the SIP is part of the ENA. Like all private link will have this particular SIP. So yeah, the key difference is for the SIP, overlay SIP, there is an encoding that needs to be applied.
Is this clear to everybody?
Yeah.
Are the people on the call familiar with these services?
So can you go back to the VNET direct mapping table? So the IP address is to 8, and then we map to .6, right? So is that the? I just want to make sure that's not.
Yeah, that is part of the VNET direct example here. Go on. So let me show you that. So in the VNET to VNET, we have different actions, right? One is, let's say VNET, right? In the VNET, you don't specify the overlay IP to look up. But the same thing for the VNET to VNET, if we specify the action as VNET direct, then it has to use the overlay IP. That is mentioned as part of the routing table for the map lookup. Even though the packet is destined to this subnet, the lookup happens based on the overlay IP from the route table. And that example is also here. Yeah, here. So VNet and VNet direct is the main difference is one, the lookup happens in the mapping table based on a specific IP. This is like kind of
no, I get this part.
Yeah.
But is there a case that somehow they don't go through the VNet direct VNet, but the destination is that .6, so then it goes to the mapping.
So not that I'm aware, because it has to match this subnets, right? So if that subnet matches the basic, and then that's where the action takes place. So
but what if the guy just send the destination IP address directly to that 10.2.0.6?
for this example, you mean here?
Yeah. Could there be a case where it's sent direct? Okay, if it's sent directly, it will match that routing
This
table.
match this, yeah.
Okay, so you are saying this overlay IP will always be within the range of
For private link, that's my understanding. But if, let's say, if it is not the same, then it will not match this, right? So I can clarify that, but I think it will have then another entry for that, for this, but this one to match for some routing table.
Okay. How many those encodings could we have? Currently, you have like 2 encodings, right? So could we have like 3 encodings, 4 encodings? Do we have a limitation on that part?
Yeah. So this encoding is what you're saying, right?
Yeah.
So it's per ENI, and here you can have any number of encoding.
Okay, so it could be maximum 128.
Yes. Maximum, yeah, I think maximum would be like 96 because the last 32 bit is always the IPv4 IP.
Okay.
Yeah.
Prince, will you share the exact encoding of the service tunnel IPv6 addresses, like what the fields mean and where they are located? Dash repo doesn't have this information.
Yeah, so that will be
No, that part I'm not sure that we want to make it generic. What do you mean by exact encoding?
Like the IPv6 prefix has VNET ID, some other fields encoded in it. But do you want to make that standard, or do you want to just leave a generic v6 prefix for people to use it as they wish?
Yeah, that's right, Mary. Like we want to make it as a generic encoding. So don't want to specify this 11 is, let's say, VNet or those things.
So we have like 96 bits of opaque data that anyone can put any information. Yeah. Okay.
So also for the service tunnel, there is no encoding per ENI, right? This is only for PL.
Yeah, only for PL. For service tunnel, the encoding is automatically detected by the northbound and they apply it here.
Okay.
So I'm wondering for the encoding, right? So whether there could be a separate format, say, you just give a mask and the bit, 128 mask and the bit, and then, then you don't have these separate fields that seems, right? So. You always give the full mask and the full modification stream, and they apply the mask and apply that, right?
So I think let me think. I think there was a challenge if we put the full mask.
You mean challenging on the vendor implementation or challenging on us?
On us. So let me think.
I saw it the same, right? So we just specify whatever the bits need to be masked out and apply the values.
Yeah. So for example, this one means like 11th offset one bit and change it to this, right?
Yeah.
So
you can have the full mask, right? So for the 11, for the bit 11, you say 1, and then there's another one. Fill the value, right? Mask and value. So you have one mask that is full 128, and you have a value full 128 for whatever you don't use. You set to 0, right? So then they don't mask out. For the one that you want to mask out and apply the value, you apply it. It's the same thing. It's just
yeah, I think it's the same thing, right? So,
but maybe it's easier for them to passing. Right? I don't know what the hardware will implement because they won't apply those field one by one, right? So they probably just you know,
Yeah,
get
value and mask is definitely easier to understand and pass to and program the hardware. And same goes by the way for service tunnel, because I saw that the last 4 bytes could be 0 or could be filled, and now I need to look into them and figure out what I should do. So if there was a value and mask again, it would be completely transparent. The operation of encoding.
Oh, so here if I put like /96 versus /128, but see, these are all source addresses as per the schema, so that's why I didn't want to put prefix and maybe like to the, okay, I think
Yeah,
this
but you
is the
can
northbound,
do
right?
like
So, but
you can do another field overlay SIP mask.
yeah, I mean, otherwise we to the side we can provide the mask, right? So you can define it that way.
Mm-hmm.
Yeah. But for encoding, yeah, we will I'll revisit this. Yeah.
And when you apply this encoding, is that all, or is that just apply? What if the fields on the original 1 or non-zero? Are you just replacing it, or are you doing the XOR, or doing?
No, this is just replacing. If it is already 1, then it is 1. So
maybe we need to clarify that.
Yeah. Okay.
Prince,
So guys, I wonder if this, oh, go ahead, Vladimir.
Yeah, just have one question. So are you planning to update the dash pipeline in relation to the service tunneling and private links?
Yeah, so that is one PR by Marianne here. I don't know if we have time to discuss that today. So this is.
No, okay, I see.
Yeah.
Maybe tomorrow in the behavioral model. It only has outbound, so inbound will be done following more details from Prince. But here you can find the transformations for the outbound, like what he mentioned, 4 to 6 encoding and then encapsulation, and 2 options for VXLAN as well as NVGRE.
Yeah, okay, I will take a look. Thanks.
Yeah, I'm wondering if this is a good breaking point. We're 5 minutes over. Hate to be a PM, but I'm sure you guys all have other meetings. What do y'all think? Gohan, Prince, Gerald?
No, I think it's good. I mean, it's I believe there's a lot of information people can review offline.
Yeah.
And
it is a lot, and I'm wondering,
yeah, so
we should save some time next week, maybe for 20 minutes or so to let people take this in and go over it. And how about that, guys? Does that work for everybody? Okay, great. I'm going to stop the recording. I appreciate all your time. Thank you for coming, especially the first lighter week after the new year and everything. So happy new year, everyone. And I'll see the behavioral model people tomorrow in that meeting. Thank you.
Happy New Year.
Okay.
Yep.
Thanks,
Thank
everyone.
you. Thank you.
Bye-bye.
Thanks, everybody.